Today, we'll explore the science behind stress and its effects on your brain and body. Stress is a natural fight or flight response, preparing the body for challenges. When stressed, your body initiates physical and mental responses to adapt. While beneficial in small doses, prolonged stress without relief becomes problematic. The HPA axis is a crucial hormone system regulating stress, energy, and mood. The HPA axis operates through a series of hormonal signals. In response to stress, the hypothalamus releases corticotropin-releasing hormone, or CRH. CRH then stimulates the pituitary gland to release adrenocorticotropic hormone, or ACTH. ACTH prompts the adrenal glands to release cortisol, the primary stress hormone. Cortisol's main function is to restore balance after stress. It increases blood flow to muscles, elevates glucose, and raises blood pressure, preparing for fight or flight. The HPA axis uses a negative feedback loop to maintain balance. As cortisol rises, the hypothalamus reduces CRH, helping the body return to normal after stress. Cortisol, a glucocorticoid hormone, is central to the stress response, affecting various bodily functions. In the short term, cortisol helps manage stress by increasing energy and focus. However, chronically elevated cortisol levels can have detrimental effects. Long-term high cortisol can suppress the immune system, increasing infection risk. Chronic stress impacts key brain areas: the prefrontal cortex, amygdala, and hippocampus. The prefrontal cortex, responsible for decision-making and attention, suffers impaired function under chronic stress. This can lead to difficulties in concentration, problem-solving, and emotional regulation. Chronic stress can reduce prefrontal cortex volume, decreasing dendritic branching and synaptic connectivity. The amygdala, crucial for processing fear and anxiety, can become hyperactive due to chronic stress. This hyperactivity results in heightened emotional responses and increased anxiety. Increased dendritic growth in the amygdala of stressed individuals may make them more sensitive to stressors. The hippocampus, essential for learning and memory, is particularly vulnerable to chronic stress. Chronic stress can lead to reduced neurogenesis, dendritic atrophy, and decreased hippocampal volume. These changes impair memory and contribute to mood disorders like depression. Chronic stress affects the cardiovascular, immune, and metabolic systems. In the cardiovascular system, chronic stress can increase heart rate, blood pressure, and inflammation. These effects increase the risk of hypertension, heart attack, and stroke. Chronic stress can impair communication between the immune system and the HPA axis. This impaired communication is linked to chronic fatigue, metabolic disorders, depression, and immune disorders. The metabolic system is also affected by chronic stress. Chronic stress can disrupt metabolic processes, increasing the risk of type 2 diabetes and obesity. Stress hormones can cause the liver to produce more glucose, leading to elevated blood sugar levels. Understanding the science of stress is crucial for managing its impact. While this video explains mechanisms, further resources offer actionable stress management advice.